Hi guys, hope you had a nice restful weekend. We are back at school. Okay, so today we are doing an introduction to vector operations, and there's sort of 4 key points here. Number 1 is finding vector opposites. Number 2 is scalar multiplication. 3, vector addition and subtraction, so you might call that 3a and 3b or whatever. And then 4, all of the above together. So we're going to, at the end of the worksheet, we'll do some problems where we do all 1, 2, and 3 mixed together in the same problem. As we work through this, we're going to work through examples that are given in component vector form and linear combination form. Component vector form is where it's written kind of like this, with those pointed brackets. Linear combination form is where you have a number in front of I and then another number in front of j, so the ij form. They're really the same thing. They're just 2 ways of writing the same thing. So you should be well versed in both of them. They're equally, in my opinion, equally easy. So hopefully it's not a problem. You will see the word resultant as we move through. Let's say the directions, let's say something like find the resultant vector. Resultant just basically means answer or result, the result of doing the work. So 5 plus 3, we call that, the 8 is the answer, or it's the sum, or you could say it's the result of doing the math. Well, if this were a vector problem, the 8, the answer, would be called the resultant instead of the result or the answer. So don't get too hung up on that word. It's just jargon. Okay, skim through this. You can see there are a total of 16 problems, which means 8 of them will be homework for you. The odds, I'll do the evens. It might seem alike. It might seem like a lot, but when you see how easy the first couple are, it'll feel like a little bit less. So here we go. Number 2, find the vector opposite of u, and u is right here. Here's how easy this is. The vector opposite of u, which is negative 3, 10, is going to be positive 3, negative 10. And that's it. Oh no, how am I going to show my work? Well, either you can say, here's my work. It's negative 1 multiplied by negative 3, 10, and oops. And then do the distributive property or something. Or you can just say, this problem is too easy to show work for, so I'm not going to do it. And I'm okay with that. So when you do number 1, you can probably just write the answer. Number 4, I think, is equally easy. The vector opposite of vector A up here is going to be positive 21i minus 28j. So opposite, basically, you flip both of the numbers to their opposite signs. Negative 21 turns positive, positive 28 turns negative, and that's it. Technically, you're multiplying by a negative 1. If you want to do that, fine, but it's that simple. So probably if I pause for 10 seconds, you can get number 1 and 3 done right now. I'm not going to do that. Okay. Scalar multiplication. About as simple as opposite vectors, a little bit more to it. Scalar multiplication is the same thing as it was with matrices. We're going to multiply 3 times f. Well, if this were a matrix, I'd write the problem like this. And then my answer would be, what's 3 times 18? 54. And 3 times negative 24 is negative 72. So if this were the last unit, we'd do it this way. Well, now they're vectors. Well, guess what? Everything stays exactly the same. We just put those types of brackets on it, and that's it. So 54, negative 72. Okay, I haven't checked my answers because 2 and 4 are so easy. Am I paranoid that I can't multiply 3 times 18 and I got to check number 6? Maybe a little bit paranoid. Okay, there it is. We're good. And there was number 2 and there was number 4. All right. So that's scalar multiplication. Number 8. Now this is in the ij form, but still 3 times u. We're going to multiply this vector by 3. So if you want to, you can treat this like a basic algebra problem and just do the distributive property. That's 36i plus 35 times 3 is 105j. You know what, let me make that 5 look like a 5. And there it is. So let me scroll down to number 8. 36, 105. There it is. So the first page of your assignment, yes, there's 8 problems. Might seem like a lot, but you can crank out 1 and 2 in just a few seconds. 6 and 8, maybe a few more seconds, but not too bad. Now we're getting into addition and subtraction. Look, this one's addition, this one's subtraction. So I'm not going to do an example of each. I'm going to leave some of it up to you to figure out. But how do I subtract these vectors? Well, one way to do it is like this. Oops. I keep wanting to write matrix brackets. I got to write the vector brackets. Okay, if you subtract this, distribute here, that's going to become a plus 3, and distribute here, that's going to become a plus 4. Negative 6 plus 3 is negative 3. 4 plus 4 is 8. That should be the answer. Let me check number 10. There it is, negative 3, 8. Do you have to do it the way I did it? Not by any means whatsoever. You could also do this, negative 6, 4. Oops. Boy, I just can't stay consistent. I can't do anything. There we go. And then you can do, okay, negative 6 minus 3 turns to plus positive 3. That's negative 3. 4 minus 4 is plus 4. 4 plus 4 is 8. Maybe make that 3 look more like a 3. Same answer. So if you understood how to do matrices, you're going to understand how to do vectors, because so far the only thing that's different is the shape of the brackets. Okay, number 12 and 11, addition/subtraction. So here, this is a little tricky, so I'm supposed to do a minus b. A is just negative 2i. If you want to, you can take your pencil or whatever and write in plus 0j. That way things kind of match up. So if we want to subtract this, it's negative 2i plus 0j minus, and then vector b is 10i plus 4j. So just combine like terms. Negative 2 minus 10 is negative 12i. And then, let me change colors. 0j minus 4j. 0 minus 4 is negative 4j. So that should be that answer. Let me check number 12. Yep. Okay, so really elementary level math. The fact we're doing this on something called vectors, and vectors has all this significance in physics and computer programming and all this stuff, it's honestly pretty irrelevant. I mean, we're just doing basic algebra here. Okay, now we're down to the point where I said we'd do all of the above. So here we have scalar multiplication, a little bit of a negative thing going on there, scalar multiplication, and addition. So we're just going to do a whole bunch of stuff. So negative 10 multiplied by vector f, which is negative 3 comma 2, plus 9 multiplied by vector v, which is negative 2 comma 0. So we are going to follow order of operations. Multiply first. So I'll distribute or multiply this and get positive 30, negative 20, plus, and then distribute this, negative 18. 9 times 0 is still 0, of course. And then combine like terms. 30 plus negative 18, that's going to be 12. And then negative 20, change colors here, negative 20 plus 0, negative 20. I said combine like terms. This isn't really a like term situation unless you think of this as x, y, x, y. So you put the x's together, the y's together. Hopefully that was fairly obvious. That makes sense. So that should be my answer to number 14. 14, 12, negative 20. There it is. Number 16 is the same thing. We're combining operations here. So we got scalar multiplication, subtraction. But now we are in the IJ form, or the linear combination form. So to do this, 10 times f. I'm going to look at that first. That's 10 times 4i plus 7j, minus 6 times g. G is negative 7i plus 7j. So I'm just rewriting this like a algebra problem where I and j are variables. Distribute the 10 here and here. That would be 40i plus 70j. Distribute the minus 6 here. That's going to be plus 42i. Distribute the minus 6 here. That's minus 42j. And then put like terms together. 40i plus 42i is 82i. And then positive 70j minus 42j. 70 minus 40 is 30. Minus 2 more is 28. So 28j. Use a calculator if you need to, if the numbers start getting a little too hard to handle. But there it is. So quite honestly, the algebra skills we're using here are multiplying, adding, subtracting, like terms, distributive property, stuff you've all done before. We're just in this new context of vectors, but really all you're doing is, thinking of vectors as x, y components, or they are variables, your numbers in front of ij, and you just treat that like an algebra problem. So hopefully you can do this pretty simply. A lot of this stuff is just like what we learned when we did matrices, and then this stuff is basic algebra. It's all the same, just kind of different perspective. As always, email me if you have questions or leave comments, and I'll do my best to answer those for you. Otherwise, do the odds, check your answers, show work where applicable. I understand in some of these you can find the answer without showing any work, and that's okay in this worksheet. All right.